Newton's theory of gravity. Isaac Newton's theory of gravity, formulated in 1687, describes gravity as a force of attraction that acts between any two objects with mass. The strength of this gravitational force is determined by Newton's universal law of gravitation. F equals g frac m1 m2 square, where F is the gravitational force between the two masses. G is the gravitational constant. m1 and m2 are the masses of the two objects. R is the distance between the centers of the two masses. According to Newton, this force is responsible for keeping planets in orbit around the Sun, causing objects to fall to the ground, and holding galaxies together. Einstein's theory of gravity. Albert Einstein's theory of gravity, known as the general theory of relativity, was published in 1915. Einstein proposed that gravity is not a force in the traditional sense, but a result of the curvature of space-time caused by the presence of mass and energy. Massive objects like stars and planets warp the fabric of space-time, and this curvature directs the motion of objects, which we perceive as gravity. Einstein's field equations describe this relationship mathematically. R mu minus frac 1 2 r g mu nu plus lambda g mu nu frac 8 pi g c4 t mu, where r mu nu is the Ricci curvature tensor, which represents gravitational effects. R is the scalar curvature, a measure of the curvature of spacetime. G mu nu is the metric tensor describing the geometry of spacetime. Lambda is the cosmological constant associated with the energy density of space. G is the gravitational constant. C is the speed of light. T mu nu is the energy momentum tensor, representing the distribution of matter and energy in spacetime. Einstein's theory has been confirmed by numerous experiments and observations, including the bending of light around massive objects, gravitational lensing, the precise orbit of Mercury, and the detection of gravitational waves. Comparison. Newton's theory describes gravity as a force acting at a distance between two masses. Works well for everyday phenomena and most celestial mechanics. Uses a simple inverse square law to calculate gravitational force. Einstein's theory describes gravity as the curvature of spacetime caused by mass and energy. Provides a more accurate description of gravitational phenomena, especially in extreme conditions, e.g., near massive objects at high velocities. Replaces the concept of a gravitational force with the geometry of spacetime. Together, Newton's and Einstein's theories provide a comprehensive understanding of gravitational interactions. Newton's theory is sufficient for most practical purposes, while Einstein's theory is necessary for understanding more complex and extreme scenarios in the universe.